Okay. So we'll talk about the failure of Mendeleev. Remember, the first failure was the position of hydrogen. Position of hydrogen is a controversial because hydrogen's property is similar to the first group element. It is also similar to the halogens, that is seventh group elements. In the Mendeleev periodic table I am talking about. Are you getting it? Any doubt? So some people are demanding to place the hydrogen in the seventh group. Some people are demanding to the what? Place the hydrogen in the first group. So the hydrogen position is controversial. The second one. Okay. Second is he did not place noble gases. He did not place what? Noble gases. Even at his time, noble gases were there, but he did not place them in, he did not give the place for the noble gases in his periodic table. That is the another failure. Third failure. Third failure, the achievement becomes the failure now. How? See here, if you see our modern periodic table, or if you see the Mendeleev periodic table, see what is the difference between modern and Mendeleev. If you see carefully, in the modern periodic table, every element with symbol have two numbers, whereas in Mendeleev have only one number. See, for example, take carbon. Here, carbon have two numbers. One is 6, the other one is 12. Yes or no? See the carbon here in the Mendeleev, it has only 12. There is no 6 there. Got it now? What do you mean by that? Because Mendeleev have classified on the basis of atomic mass. So only atomic mass are there in the Mendeleev periodic table. Follow the atomic mass. For example, if you follow these numbers, lithium, what is the mass of the lithium? See, lithium have 6.939, beryllium have what? 9.012, boron have 10.81, carbon have 12.011, enough, this much. Okay. Now imagine, now see here, these numbers, do they have common pattern? Arithmetic progression we have studied. The numbers which have a some pattern 2, 4, 6, 8, 3, 6, 9, 10, 12. Okay, which has the same common difference is known as what? Some pattern. Does these numbers have any common pattern? No. 6.9 to direct 9.01, 9.01 to 10, 10 to 12. So he left, imagine he left here one place and he told in future one element will come. Now my question is, only one will come, not more than one, because numbers does not follow any pattern. Might be 2 or 3 elements will come in future, and if you place only, if you have left only one place where the other two should sit. Understood? He left the space right for the upcoming elements, but question is how many places should be left, that is unknown. Are you getting it? His achievement become a failure. That is the third failure.
After 60 years.
Okay.
After 60 years.
Not after 60 years, man. We are talking about the failures. Okay. And because of these failures are not so big that we can what? Eradicate. We can what? Stop using it. These are not so big failures. Like how in modern periodic table also there are some failures, but still we are following it. The major failure which is coming now, which I will explain you, because of which it is stopped using, is what? Is the discovery of isotopes. Is what? It is the discovery of isotopes. At his time, isotopes were not discovered. Later it is discovered. Okay. So major, very major failure, because of which we have stopped following the periodic table of Mendeleev, is the, say, discovery of isotopes. What are isotopes, man? Isotopes are the elements with the same atomic number but different mass number, and he have classified on the basis of atomic masses. Example, so we were thinking that there is only one type of hydrogen in nature. but we came to know that there are actually three types of hydrogen. One is 1H1, the other one is 1H2, the other one is 1H3. Protium, deuterium, tritium, these are the names of the hydrogen. We have three different types of hydrogen in nature, and they have different what? Atomic masses are different, and he have classified the elements on the basis of atomic masses. Because they have different atomic masses, all three should be placed, yes or no? Similarly, carbon have what? Okay, C12, we have C14. Chlorine we have what? 35. Chlorine 37. There are elements where with many isotopes. अगर सारे आइसोटोप्स को प्लेस देंगे किसमें? पीरियोडिक टेबल में, तो मोर देन 1000 क्या हो जाता है बोलो? एलिमेंट्स. देयर विल बी मेनी एलिमेंट्स, एंड दैट पीरियोडिक टेबल बिकम व्हाट? जंक. वी कैन नॉट यूज देम. आर यू गेटिंग इट? We cannot give the all these three places for the hydrogen, yes or no? There are elements with 10 isotopes. If I give the place for all the isotopes, the periodic table become very vast. Nobody can understand it. So this was the major drawback. Okay, after this, the last person, whose name is Henry Moseley. What is the name of the last person? Henry Moseley, who have classified the element, and that periodic table is known as modern periodic table, which we are using it. Okay, which we are following. Now listen here. Next person, okay, fourth, right? Is the fourth. There are many persons. These are the renowned. Renowned means what? Famous personalities which they have discussed. There are many people who have classified. Okay, Henry Moseley. Okay. Now Henry Moseley tried to classify the elements. Listen here, the one who comes, for example, okay, when the Newland have came, Newland should remove the failure of Dobereiner. Mendeleev should remove the failure of Newland. Similarly, Henry Moseley should remove the failure of Mendeleev. Yes or no? The one who comes update, no, how we update the apps. So whatever problems we have in the previous app should be removed in the future app, updated app. Are you getting it? It is updation, what we can say. Understood, man? Now listen here. When Henry Moseley came, the biggest challenge was placing of isotopes, giving the place for isotopes. Then they thought that all these who have came and classified, they kept the base what? Same. Might be because of the same base, they all have what? Failed. So I should what? Search a new base. Understood? So he tried to search what? A new base, and surprisingly he got atomic number. What he got? Atomic number. He told that why can't we classify based on what? Atomic number instead of based on atomic mass. Because mass is not followed regularly. There is no common pattern in the increasing atomic mass, whereas atomic number have proper pattern. You can see in our modern periodic table, these numbers are atomic numbers, which are like 1, 2, 3, 4, 5, 6. It is a natural number. Like, are you getting it? So atomic number have a proper pattern. So why don't we use what? Atomic number instead of mass number? And are you getting it? That is the one thing. So he classified the elements on the basis of atomic number and physical properties. Okay, so little bit changes he did. He have classified on the basis of atomic number and physical properties. Physical properties. So base is finished. Now what? We have to give one principle. Now the principle, see, he copied the Mendeleev's principle. He told that Mendeleev was correct, but instead of mass, he have to use what? atomic number. That's it. So he told the physical and chemical properties of an element are the periodic function of their atomic number, not masses. Understood? This law is known as modern periodic law. Which law? In the place of mass, write what? Number. Becomes a modern periodic law given by whom? Henry and Moseley. Then he followed Mendeleev's only. What was the problem in Mendeleev? He did not give a place for what? Helium, noble gases. He gave the place. And he kept one hydrogen in the first group like how Mendeleev kept. Almost Mendeleev what? Periodic table is much similar than our modern periodic table because he have classified nicely based on physical properties. Same thing he followed. Now the problem of what? Isotopes. He told that instead of placing all these three, instead of placing 1H1, 1H2, 1H3, what we'll do, we'll take one H symbol will keep, and their atomic number is 1, no? Everyone, all these three elements have one atomic number. So I'll say with one atomic number. But for the mass number, we'll take the average of them. What will take? Average. Average based on their percentage of existence. Average based on their percentage of existence. That's the reason we got the average of all these three, we got 1.0008. Are you getting it? Understood? So what we have did that that taking the average atomic mass is discussed in first PUC. Okay, so that is in 11th standard. We will be dealing there with that, and you have to find out. It's very much easy. तो कितना परसेंटेज का प्रेजेंट है ना, उसके हिसाब से क्या ले लेते हैं, एवरेज ले लेंगे तो we'll get it. Got it now? So he have solved all the problems and he have given a new periodic table that is known as modern periodic table. So in the Henry Moseley we have to just read the law. No need to read the failure because it is not yet failed. We are following it. Understood? So what and all we have to study in this part? First of all, Dauber-Inner law of triad and its failure. Then Newland law of octave and its failure. Then Mendeleev's law of periodic table. Then what? Its achievement and its failure. And the lastly we have to go with the law of the modern periodic law given by Henry Moseley. That's it. This completes our first part. Okay, in the next class I will go with the second part, that is modern periodic table.